Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to AWS Community Day Pakistan. And today, the topic of my talk is scale engineering using cloud, and specifically AWS cloud. My name is Hussain Mansoor, and if you want to know more about me, you can visit hussain.dev. A brief intro about me is that I have two masters, one from Malaysia and one from UK, both in software engineering. And I worked for Malaysians and Australian organizations in Malaysia, and I was in Malaysia for the past 6.5 years, and I recently moved back to Pakistan. Here in Pakistan, I'm working as engineering manager at Airlift Technologies, which is a grocery delivery application across 9 to 10 cities in Pakistan, and growing rapidly. So let's start our talk. So what is engineering? Programming or developing features, coding, is that what engineering is? We are specifically talking about software engineering, so obviously we have to deploy it somewhere. So deploying to cloud is engineering, or you can say that we have a strong engineering team if we have DevOps or systems engineers, or project managers, or pseudo agile practices, like we do daily stand-ups, but we don't believe in retrospectives. Is that engineering for you? For me, a real engineering is proper processes which empowers teams and decision making. If you follow Kaizen practice, or in other simple English, continuous improvements, you're continuously trying to improve your processes, improve how you code, how you develop features, how you release, how you build, and everything. Agility in mindset as a culture, not specifically one team or one division, but everyone have this agile mindset, like let's focus on delivery, let's focus on solutions rather than problems, and let's work together. That's what engineering is. Defined and documented workflows and requirements. If it's not documented, you're not doing proper engineering. So you should have diagrams. If you have API contracts, obviously they should be documented. Your requirements, whether in knowledge base or ticketing system like Jira or anywhere, but they have to be properly documented. And properly documented, I mean UI should be documented, positive scenarios should be documented, negative scenarios, unit test, integration test, everything. The requirement should be complete. Then architectural diagrams and architectural decisions, why solutions architect or tech lead or team lead have decided to implement something in using some particular tools and technologies. Why have they chosen those tools and technologies? So architectural design records, ADRs, in short, should be documented. Your teams should be cross-functional, right? And end-to-end automation and incident management, and most importantly, feedback loops should be there. Now, the second point is scale. So, what is a scale? Well, scale is simply a number of users, or orders, transactions, or revenue. Any of these things could mean scale for you. Depends on the product. In terms of engineering teams, number of engineers is also a scale. If you are 5% team and suddenly if you have to manage 200 engineers, it's a totally different ball game. Managing 200 engineers will require a different set of skill set, a different set of leadership skills. Bills of services, AWS bill, Google API bills, Microsoft or G Suite bill, so these monthly recurring charges. Scalability could also be defined in number of systems or applications. How many applications are there? How many systems are there? How many microservices are there? That is also scale. Or it could be in order of complexity. How complex is the overall system? Increased complexity means that it's a scaled system. It's a scalable system, or it has already scaled. So how do we manage these two aspects, scale of engineering in terms of cloud. So let's focus on that. I want to start with anti-patterns first. What are some of the anti-patterns to manage cloud? Or when you start with 3, 4, 5 people as developers, in your engineering team, but when they grow to 200, even 100 engineers, how you manage cloud, you have to rethink that. And these are the anti-patterns which everyone follows here and there, and they think that they are following best practices, but in reality they are not. So first point is, as soon as they scale, they think that they should go multi-cloud because one cloud is not good enough. That's totally wrong. Giants like Netflix and Uber, they are not multi-cloud, right? They deploy everything on AWS. Then what is the proper solution? I'll come back to that later, but let's just focus on the anti-patterns first. Then one AWS account for all the environments and all the systems. Environment could be dev, QA, staging, prod, and systems could be, it could be your payment system, it could be your user management, it could be your notification system, it could be your core business logics, whatever. Deploying everything to one AWS environment or AWS account, you're just inviting chaos. So that's a great anti-pattern. Don't do that. Managing everything via IAM. If you have 100 engineers, you have definitely more than 100 IAM users in your AWS cloud, and then you will create 100 so API keys, secret keys and token keys, and then you have to manage sessions, and then who is coming in and who is moving out, and roles and groups and access rights and so much more. So managing everything using IAM. Then one more anti-pattern is that no documentation. Well, the source of truth is the cloud itself, or source of truth is the code itself, as we so speak. That's an anti-pattern. No, it's not, right? You will face issues like your dev environment is not same as your pre-prod environment, and pre-prod environment is not same as your prod environment, which it should be. Your pre-prod should mimic your prod environment, but if it's not same, you will have a lot of bugs and a lot of issues. So that's an anti-pattern. And finally, not moving towards ISE, infrastructure as code. ISE is extremely important, and a lot of product companies thinks that just cloud is in front of us, console is in front of us, we can manage everything from there. No, you can't. So these are some of the solutions. Instead of multi-cloud, go poly-cloud. Poly-cloud means that use cloud for their expertise. Well, AWS is enough for about 90% of the use case, but let's say for that 5% use case which require some Google service, let's say BigQuery or Bigtable or Big Data, right? Then you can use GCP for that. Or if you have for data residency, let's say you have to store your data in your local on-prem server, then for that, yes, go ahead and use physical servers, but everything else, cloud is good enough. So multi-cloud should not be the target, but poly-cloud is. Then create different AWS accounts. Creating AWS accounts is free. You don't have to pay to create a new AWS account. You can have a parent account, which is your billing account, and all the other child accounts are just free. It just requires one unique email address to create an AWS account. So create different accounts for your dev environment, staging environment, prod environment. Even create different environment for different services. So all the services are just black box to each other, not in terms of functionality, but even in terms of connectivity. Okay. Then instead of managing everything via IAM, use SSO, single sign-on. Please use that. At least use AWS provided SSO. But if you're already on Microsoft Suite or G Suite, use that. Okay, if you're not, then Okta is a website, as a tool, is amazing. Use that for SSO, but you have to move to an SSO based solution. Then finally, documenting at a high level, at least architectural diagrams, network diagrams, flow diagrams, how each system interact with each other. That is really important. Also mention what type of services you are using. If you're using CloudFront, mention that. If you're using Route 53, mention that. If you're using GoDaddy and not Route 53, mention that on the diagram. At a high level, everyone understands what's going on and which services are involved. Finally, your core services, at least bare minimum, should be deployed via ISE. Don't provision everything manually. Move towards ISE. It starts with serverless. That's the easiest thing to pick up. Serverless infrastructure as a code is just YAML files. You can use AWS provided serverless architecture, or you can use serverless SLS tool. Both are fine, but start moving towards it. You'll see the benefits when later on, when you have tens of hundreds of engineers. Nobody would remember how many services are there or what are the config. Then you have this code and you can look at it and you would know that what's being deployed and what's being provisioned. And then you can manage this ISE and apply all the best practices of programming on this ISE. So you can deploy your environments via pipelines. You can pull request them, you can review them together, and you can do so many things. Now these are some good to haves in terms of cloud when you scale. So different dashboards for business and different dashboards for tech. So how much CPU is being used, how much RAM is being used, how much IO, your business simply should not care about these things, right? That is your DevOps teams or your systems engineering teams target. So create different dashboards and make them available for everyone in the organization. If it's possible, put them on the TVs across your office, but different dashboards. Second most important part is OPEX versus CAPEX budget for AWS account. So one can argue that AWS or any cloud is a pay-as-you-go billing, right? It's utility-based pricing. So why should we even put aside budgets for it? But no, that's not the right mindset. Your dev and non-prod environments should be your CAPEX. You should allocate some budget for them because they are static. They don't scale up and down based on the end users usage. So they are your CAPEX, and your production environment should be your OPEX. So that depends on how much traffic is there, how much your users are using it, right? So these are different. Allocate separate budgets for them. Then separate out your systems engineering team from your support team. So your support team should be up and running 24/7. Their metrics are different, but your systems engineering team, which manage your cloud, which manage your architecture, which manage your integrations, should be different. They are not one. They are different teams. Their targets are different. Consider them as separate teams. And then finally, treat your infrastructure as you treat your code. It has some health, so define how healthy it is. Consider optimization practices, consider audits. Everything you do with your product, do it with the infra as well. So these are some good to have, some advanced topics which if you scale you should consider. Now finally, after good to haves, there's something furthermore. There are some advanced practices which one should adopt if they definitely are growing and have the demand for. What are these? Adopt Tech Radar. Tech Radar is an amazing tool which reduces tech brawl. So different teams, if they are empowered, if they are cross functional teams, they will pick and choose different technologies based on their preferences. And if you just openly allow everyone to choose whatever they want, then at one point in time you will have tens of languages in your organization. So this is brawl. You should reduce this. So go ahead. ThoughtWorks presented this idea of having a tech radar. They publish their own tech radar every quarter, but a mature engineering organization should also have their internal tech radar. Then as you scale, you should also have platform teams. So platform teams are, if you have a lot of data, instead of assigning everything to DevOps team or assigning everything to your senior developers, you should have platform teams which manage your data. Then you should have security teams which should manage your security, and legal team and finance team. So these are all different platforms which will enable you to scale further. Third point is adopt everything as code concept. Infrastructure as a code, document as a code, diagram as code. There are a lot of tools out there which will help you in all of these things. Read about them, pick and choose whatever works for you, but everything is code, so that you can apply all the best practices of coding and get some amazing outcomes from it. Fourth point is amazing, Yagni principle. Try to implement this as much as possible. So what is Yagni? Yagni is you ain't gonna need it. It means you don't need it, whatever that could be. So most of the times we an example is you need a ticketing system. You are planning how many statuses one ticket can have, assignments and priorities and everything. Well, there's a tool called Jira for it. Just use Jira rather than creating your own, and it could be anything else. So instead of reinventing the wheel, DRY principle, don't repeat yourself. There's something Yagni as well. You ain't gonna need it. Figure out if there's already something, or figure out a non-tech solution. That is always better than a tech solution, because code is a liability. You have to maintain it. And then finally, real agile environments. If you following Scrum, then you should have retro meetings, then you should have proper grooming, then you should have proper sprint plannings, you should have sprint goals, and you should have burn down charts and everything else. And if you're following Kanban, then it does not mean that maintaining a to-do list is enough. Running Kanban is more complex than running Scrum teams. So hire somebody who can teach you all this, who can run all this. And real agile environments means that a team can decide when to hire. Team can decide what technologies they want to use. At scale, it will help you. At a scale, you can not, or you should not do micromanagement, right? Owning all the individual aspects of your teams, their outcomes and their day-to-day work, that's just not gonna scale. So real agile environments. So these are some of the practices which I consider as advanced practices for scaled teams, and we discussed some good to haves, some anti patterns and their solutions. We saw what does a scale look like. We saw what is engineering, right, and what could be some good practices of engineering. And I would say this is the end of my talk. I hope you have learned something out of it. If you want to reach me out, you can reach to any of the AWS community Pakistan team members, or you can search for me at hussain.dev. Thank you very much. I hope you learned from some other amazing talks whole day, and wish you best of luck in your cloud journey. This is Hussain Mansoor. Allah Hafiz.